Hello and welcome to my presentation about the security of cyber physical systems. My name is Armando Capote and I will be discussing the security aspects that surround cyber physical systems. In recent years, cyber physical systems have emerged from traditional engineered systems in the areas of power and energy, transportation, healthcare, and manufacturing, among others included in the list below. By introducing communication support in those systems, they have become more flexible, performance-oriented, and responsive. In general, these cyber-physical systems are also mission-critical, being that their availability and correct operation is essential. A cyber-physical system can essentially be described as effectively integrating cyber intelligence and connectivity with physical components in our everyday lives, giving them the ability to process and provide computing power while also being network connected in order to provide a service much like the Internet of Things provides. Some of the industries that cyber physical systems can be found in are communications, consumer, energy, infrastructure, healthcare, manufacturing, military, physical security, robotics, smart buildings, transportation, and many others. Cyber-physical systems are essentially feedback systems consisting of being networked and distributed, adaptive, predictive, intelligent, and real-time. I will discuss each in a little bit more detail. Network-controlled theory assumes continuous or discrete timing and signaling, where the controller continually or periodically observes the physical subsystem and continually or periodically provides actuation to the system. In a typical cyber-physical system architecture, the signaling is mediated by software and networks that do not have such continuous periodic behavior. Adapting control theory to handle the realities of software and networks is an important cyber-physical system problem. Adaptive. Cyber-physical systems are typically closed-loop systems, where sensors make measurements of physical processes. The measurements are processed in the cyber subsystems, which then drive actuators that affect the physical processes. The control strategies implemented in cyber subsystems needs to be adaptive. In the attached image, you will see some examples of cyber-physical systems. I will now go over some of the industries and markets that cyber-physical systems can make an impact and how they make that impact. In communications, digital control and the contention for physical resources such as radio spectrum and fiber channels, communication systems are intrinsically cyber-physical systems. Cellular backhaul, sensor networks, and wireless networks are all examples of that. In the energy industry, energy production, distribution, and optimization are all cyber-physical problems. For example, the smart grid combines multiple electric power production plants with varying loads using dynamic load balancing and dynamic pricing with demand response strategies. Smart buildings integrate sensors, typically wireless, into control systems for lighting, HVAC, heating, ventilation and air conditioning, and safety, fire monitoring, and evacuation. In the infrastructure industry, society depends on critical infrastructure, electric power, water, roadways, etc. Cyber-physical systems can help manage and maintain such infrastructure by providing disaster recovery, structural health monitoring, water distribution optimization, and water safety monitoring. In healthcare, many healthcare systems are cyber-physical systems. In hospitals, for example, information from many sources like bedside monitors, lab results, and practitioner observations are combined to inform interventions. Today, many components of the health system operate in isolation and some limited integrated solutions are available. In the future, they will be combined into networked, closed-loop systems with humans in the loop to provide medical workflows and patient safety. Emerging technologies aimed at enabling remote care of patients will provide care practitioners with information on how activities of daily living affect healthcare and allow practitioners to make more informed decisions about interventions. The combination of these two currently separate aspects of healthcare would transform the healthcare system into one large and complex and safety-critical cyber-physical system with many advantages as well as challenges. In manufacturing, manufacturing systems that include robotic machinery, embedded vision, or any computer-controlled actuation are cyber-physical systems. For the military,